So today we're going to talk about composition of functions, and this is lesson 1-3. So the question is, what is composition with functions? So as you're looking at this slide, the notation, it looks like fog, F-O-G, but this little open circle is really what denotes a composition. So it is read F of G of X. And this is an alternative notation, so they just drop off the of X part, or you can write it like this. And really, what we're doing with a composition is we're taking the first function, f, and we're going to substitute in for every x in the first function, a second function. So the g of x, if you recall from when we were looking at function notation, this right here is your input. So we are going to substitute into one function an entire another function. For instance, what if we had, what if f of x was equal to, let's say, 2x plus 3, and g of x was equal to x minus 5. So if we are going to find the composition, we're going to find f of g of x. Oftentimes teachers will call it fog. And then that means that I'm going to take the f function and substitute it anywhere that I see an x in the f function, the whole g function. So always start off with the leftmost or the first function that is showing. So the first function that's showing is f. So I'm going to take the f function and I'm going to write it exactly as it looks, but instead of the x, right here, I'm going to leave just big parentheses. So instead of that x, I'm going to write 2 big parentheses instead of the x plus 3. So hopefully you'll agree that 2 times x plus 3 is what the x function is saying. So the composition just means that we're going to take this whole g function and substitute it in wherever you see an x in that f function. So we're going to put an x minus 5 in there, and we're going to come out with a whole new function. So you start out with 2 functions, and they're going to merge together to create a third function. And so then we're going to follow our operations. I'm going to distribute the 2, so I get 2x. Distribute the 2 to the negative 5, I get minus 10, and then plus that 3. Then collect like terms, I get 2x minus 7. So f of g of x is 2x minus 7. Well, we can also reverse this and do GOF. G of f of x. So it looks like GOF, G-O-F. But really we're going to take the g function, and anywhere there's an x in the g function, we are going to substitute in the f function. So again, the g function is right here. So we're going to start off with writing down x minus 5, but instead of x, I'm going to put big parentheses. So instead of x minus 5, I'm putting parentheses minus 5. Again, this is no different than x minus 5, but I'm leaving that blank because we're going to substitute in the f function right into here. So that f function is 2x plus 3. And then we're just going to follow our operations and do whatever we can to simplify it. So there's nothing in front of the parentheses to distribute, so we can just drop them. So that's what I will do. So I get 2x plus 3 minus the 5. Collect your like terms, and I get 2x minus 2. And that's what we're going to practice doing today, fog and GOF. So let's look at example 1. I'm going to move this up a little bit higher. So example 1 says that The f function is 6x minus 1, and the g function is 2x plus 3. Then we're going to determine fog and goff. So I'm going to do one on one side and one on the other. So we'll start with fog. So I've got f of g of x. So that's my fog. That's this one right here. And so because we start with the f function, we're going to put this one first, and then we're going to substitute into it the g function. Okay, so here we go. So our f is 6x, so instead of x, I got big parentheses and then minus 1. So that's your 6x minus 1. And inside the parentheses, you're going to put the entire g function, 2x plus, you know what, I'm going to do that in red because you can't really see that, 2x plus 3. So that's squeezed in there. And then we're going to apply our operations. We're going to distribute. So I get 12x plus 18, and don't forget to bring down that minus 1. Then collect your like terms, and we end up with a function that is 12x plus 17. So f of g of x is equal to 12x plus 17. Then we're going to do goff. So I'm going to do g of f of x. So I'm going to substitute the f function into the g function. So I'm going to write the g function first because it comes first. So I've got 2x plus 3. So 2 instead of the x, big parentheses, and then plus 3. Then inside those parentheses, we started with the g function. I'm going to take the whole f function and substitute it in here. So here we go. The f function is 6x minus 1. Now you just use your algebra. We're going to distribute to simplify, so we get equals 12x. 2 times negative 1 is negative 2 plus 3. Collect your like terms, and we get equals 12x plus 1. So g of f of x is equal to 12x plus 1. Example 2, again, they're just giving you the problem in a different way, but you've been given an f function right here and a g function, and we're just going to do fog and goff. So here we go. So I'm going to do fog down here. So f of g of x equals, so I'm going to start with the f function. It's x squared plus 4. So I've got big parentheses squared plus 4. Then inside, I'm going to take the g function, which is 7x, and I'm going to substitute it right in here. So the g function, 7x, gets substituted in, and then we're just going to simplify. So you've got to square the 7 and the x. So 7 squared is 49. 7 times 7 is 49. So we get 49, and then the x squared is x squared plus 4. Then g of f of x is equal to, and we'll talk about this negative 3 here at the very end. But assume that we're going to find g of f of x first, and then we'll deal with the fact that they have changed what used to be an x right here and for a 3. So instead of g of f of x, they have a negative 3 there. So we're just going to find the composition first. So we'll start with the g function, which is 7x. So instead of x, we've got big parentheses. And inside those parentheses, I'm going to take the f function and substitute it right in here. So the f function is x squared plus 4, and then we're going to simplify by distributing. So I get equals 7x squared plus 28. Now, I'm going to deal with the negative 3. So what that is telling me is I've got to take this negative 3 and input it into this composite function that we came up with. So I'm going to take the negative 3 and plug it in here. So I'm going to find g of f of negative 3. Okay? So I'm going to take the composite function that we just came up with, wherever there's an x, I'm going to put parentheses, and then I'll replace that with that negative 3. So order of operations say that we must square the negative 3 before we multiply it by a 7. So you cannot multiply by 7 and get negative 21 and then square that. You have to square the negative 3, which is... So negative 3 squared is 9, plus the 28. 9 times 7 is 63, plus 28. And 63 and 28 is 91. Now you could take this negative 3 and you could plug it into the f function first. So we could take the negative 3 and plug it in here first. So negative 3 squared would be negative 3 times negative 3, which is positive 9, and then add the 4, which is 13. And then you could take that value of 13 and plug it in for this g function. So 7 times 13 is 91. So that's the other way that you could do it. You just have to work yourself backwards. Take this, whatever number they put here, put it into the first function as you're working backwards. So put it into this function first. That's why I put it in f first. And then take that value and input it, substitute it into the next function, in this case g. But both ways give you the same answer. I just tend to find kids do a better job and less mistakes when they do it this way. All right, so example 3. So this time we're doing the same thing as we did in example 2, but starting to get a little bit more difficult. So we're going to start off with h of m of x. I'm going to do my work down here. It's just easier to see on the white background. So h of m of x is equal to. So we start with h. So h is 2x minus 6. So I'm going to have 2 instead of x, big parentheses, minus 6. Then you're going to substitute your m function right here all the way into here. So I'm going to substitute in 3x squared plus 1. Then use your algebra to simplify. We're going to distribute. 2 times 3x squared is 6x squared. 2 times 1 is positive 2 minus the 6. Combine your like terms. You get 6x squared minus 4. That's it. So then the question says, what about vice versa? Vice versa just means to switch it. Instead of h of m, we're going to do m of h of x. So I'm going to do that down here, which means I'm going to take the m function and substitute the h function into it. Let's see what we get. So the m function, 3 big parentheses squared plus 1. So I'm going to take the h function, which is 2x minus 6, and substitute that into here. That's where you have to be careful. This is the hard part. So we're going to substitute in 2x minus 6. Here's the problem. 2x minus 6 squared is not 2x squared, which is 4x squared, minus 6 squared, which is 36. It actually has a middle term. So you have to write out 2x minus 6 times 2x minus 6, and you cannot distribute the 3 into the parentheses before you square it either. So order of operations say you have to square it exponents before you ever multiply. So this is going to take a little bit of work, but we're going to do 3, and then 2x minus 6 squared is 2x minus 6 times 2x minus 6, and then don't forget that plus 1. So then I'm going to multiply this together first. So the 3 is going to come out in front, and then I'm going to distribute, or FOIL, double distribute. So I got 2x times 2x, which is 4x squared. Then I have 2x times negative 6, which is negative 12x. Then I have negative 6 times 2x, which is another negative 12x, and those do not cancel each other out. They're the same sign. And then negative 6 times negative 6 is positive 36. Parentheses plus 1. Then I can distribute the, oops, I did not mean to do that. Let's move that back. Then I need to distribute the 3 all the way in. Oh, well, we'll combine this. So I'm going to have to distribute the 3, but before I can do that, I'm going to have to combine like terms. I forgot to do that. So I get 4x squared minus 12x, and minus 12x is minus 24x plus the 36, and I still can't add the 1 yet. Now I can distribute the 3. So we'll try that. Distribute, distribute, distribute. So I get 3 times 4x squared is 12x squared. 3 times negative 4 is negative 72x. And 3 times 36 is positive 108. And now I can finally add the 1. So these are the only like terms. So my final answer is 12x squared minus 72x plus 109. So note to self, if I were you, I would highlight this right here. So big highlight, write yourself a big note. I'm going to put that in red. Be careful. So you have to make sure if you have a squared binomial, you write it out the long way. 2x minus 6 times 2x minus 6, or whatever it happens to be. Okay. And that should get you through the rest of the lesson. If you have any questions, please don't hesitate to text me or email me.